You're starting with a 2D shape and you have to figure out what 3D shape it's making. Okay, so we're going 2D to 3D. So if I have a rectangular prism and I'm a ninja and I slice it, okay, where that little line is showing how it's like slicing it, what two-dimensional shape, if I tore that thing apart and opened it up, what 2D shape would that be making? It would be it's not a rectangular prism anymore. Like each side would be a rectangular prism, but you're thinking about what 2D shape the slice is actually creating. So if I open it up and I look at it, it's making it's not a rectangular prism. Does anybody know? It's a rectangle. So we're talking about like this inside piece right here. So if I slice it like a ninja, this middle piece would be a rectangle. Yeah. Okay. The second one is a cylinder. So if this is my can of cherry Coke, okay, and I'm a ninja and I slice it and I open it up, what two-dimensional shape would be made? A circle. That's easy. So it's like this inside shape. So take a second, try 3, 4, 5, 6. Easy peasy, lemon squeezy. You just have to visualize like what 2D shape is being created when you take a cross section. A cross section is technically where it's like slicing it, cutting it open. Oh no. Welcome. Okay, what do we think 3 is going to be? Circle. Okay, that was easy. If I cut this sideways diagonally, what shape would that make? A square. Pen is running out. For this one, this is a triangular prism being sliced vertically. It's a rectangle. Oh, there it goes. Does anybody know what this one would make? It's a polygon. What kind? A pentagon. So a pentagon, most people all day have been calling it a hexagon. A hexagon has 6 sides. A pentagon has 5 sides. So if you don't remember that from English, that was a little hard. So these are easy. You're going from 3D to 2D. That should not have been too bad. Okay, now this is where it gets a little tricky. So what we're going to do is we are going to rotate a 2-dimensional shape around a line to make a 3-dimensional shape. So if I take a square or a rectangle, that looks like a square. If I take a square and I rotate it around, okay, so I'm like rotating around, like, does anybody think they know what 3D shape would be created? Not a prism, not a cube. A cylinder. The reason why is because, and this is gonna suck for the YouTube kid. Here, gonna watch this. So if this is like my x-axis and I'm taking my like rectangle, so it's my rectangle, my 2D shape, okay, and I'm rotating it around the x-axis, it's gonna spin. It's creating a circle along the side, but it still has a width of the piece of paper. So this is creating a cylinder. It's circular, it's spinning. So this is really, and I'm going to try to draw this. So it's going to spin around like this. This one's going to spin around like this. And then it's like connecting. So there's like a cylinder. So it's a cylinder on its side. I'll color it in because I think it's easier to tell whenever it's like shaded in 3-dimensional shapes. Does that kind of look like something? It's like on its side. So this is where you have to have an imagination and people get confused. Okay, this one is not a shape that we've talked about. This is a real life shape. Now the catch with this is there's a space between the line and the circle. So before this would be a solid cylinder, like a solid can of Coke, okay? This one has a space, so there's gonna be a gap in the middle. If I take a circle and I rotate it around the line, what real life kind of shape would this make? Not an oval. A donut. So if I curve this, if you think it's literally a circle and it's rotating around, that would look like a donut. It's hard to like visualize, but I'm gonna try my best to draw a donut. So that's like my opening because this is hollow in the middle. That's like the bottom of my donut, I guess. I don't know. I'm gonna like spin around. This is like geometry, don't you know? Yes, this was on cycle 3. It like you have to visualize it. I can't draw a donut, guys, but like if you take a circle and you go around in a complete circle, it's making a donut. This is the one that was on cycle 3. If you take, normally it's going to be up against the line, so this one's not hollow because there's no space. If I rotate a triangle, it would be a cone. So if I kind of rotate this around, I looked for like 30 minutes for like an online representation of this, like of somebody doing some weird math stuff, like, or like a 30-second like clip of like showing it, but there was nothing. And I was going through a bunch of craziness and I could not find anything because I was like, this is not going to be good because either people get this or they don't, but it's rotating around. So this is representing, oh, so let me write donut. This is a cone. Okay. So this one, let's decide, is this going to be hollow or is it going to be solid? Hollow because it's got a little gap. Okay, so we know we're gonna have a gap. It's gonna look, I don't know. There's gonna be like a middle section because it's rotating around. What? Not a cylinder. It's not a donut. It's kind of like a funnel. So it's kind of like somebody last class was like, it's like a volcano. It's like a volcano. So it's gonna have the point on both sides. Somebody from first period said it looked like a lampshade. So it's got the missing top, it's hollow on the inside. It's kind of like a funnel, it goes down. So this is technically like a cone, a hollow cone. So we'll call it, it's called a funnel. I think that's how you spell funnel. Yeah, lampshade, volcano, whatever. On the EOC, they're not going to have you like type in words. It would basically give you the picture and then it would give you images of like 3D shapes and be like, which one would it make? So it should be easy to kind of like pick out what shape it would make. So the next type is we have a hollow cylinder. It tells me to draw a shape. So I'm drawing a 2-dimensional shape that I could technically rotate around the x-axis. So the x-axis is going through the center, basically. It's hollow, so it's not touching the x-axis. What 2-dimensional shape would I have to draw for it to rotate around the x-axis to create a hollow cylinder? Not a square, a rectangle. So technically, if I had a rectangle, like a little, so I'm going to color this in. If I had like a thin rectangle and I rotated it around the x-axis, it would create that hollow opening because it's not touching the x-axis, and it would make a circle to make a cylinder. So what we're going to do is we're going to make a rectangle on our graph, and it doesn't matter the width. The only thing is, because it's hollow, it cannot touch the x-axis. So it doesn't matter where you're at, as long as it's a rectangle. So on the EOC, they could give you this question and you would have to draw the shape on a graph. It doesn't matter the width. The key is it should be a rectangle and it cannot touch the x-axis because the x-axis makes it hollow. So what if I made my shape vertical? What would it be? Still a rectangle. It's just vertical this time. What axis can it not touch? The y-axis. So I'm going to draw just like a rectangle. Doesn't matter the width, doesn't matter the length. There's my little rectangle. If I rotated around the y-axis, it would make a 3-dimensional hollow cylinder. Okay. Let's do one on the back to refresh your brain. And then that we have an example of an EOC question. So the back is from like chapter 2, I think. So let me flip to the back. Let's do number 7. I put some graph paper over here so that we have some scratch paper because they're going to give you those like yellow booklets with the graph paper. So you get some graph paper on the EOC. So it's like your scratch side. So we're going to do number 7. It says on square BCDE below, if E is located at yada yada, D is at yada yada, C is at blah 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 blah. Find the perimeter of the square. So if you're given a question with coordinate points, what should you probably do? Plot it. When in doubt, draw it out. So on the EOC, there are going to be questions. It's not going to be even going to give you a picture like this. To make questions just like that without any picture, use the graph paper they give you to plot it out. So let's plot our points for number 7. We have to find the perimeter. Can we just count the spaces? No. Why can we not just count the length? Because it's diagonal. If it was straight or perfectly vertical, like if it was horizontal or vertical perfectly, then you could just count physically up. We're gonna make a little triangle. So when we did this, we technically, and you can, this is nice because it's a square. A square has all congruent sides. So I'm gonna make a triangle out of this. So I'm just gonna go straight down. It doesn't matter what you use, like what side you use. I'm gonna go straight down and then over. Hey, I heard that. It's not nice. This is on your EOC. Don't hate this problem. Okay, so there's my triangle. Does anybody remember what we did next after we made a triangle? Count the sides. So I'll make a little triangle over here. So what's the height of my triangle? Okay, so now what did I do with that triangle? Pythagorean theorem. So the Pythagorean theorem is going to find the hypotenuse. It's going to find the distance of that. And then I can use that to find the perimeter of the square because a square has all congruent sides. So I only need to do the Pythagorean theorem once. So we're going to do 4 squared plus 6 squared. Yes. Yes. 4 squared, 16 plus 36. When you add them, you get 52. Don't forget, you have to square root. And then we're going to round roughly, say 7.2. Now, the goal is to find the perimeter. A square has 4 congruent sides. So you're doing 7.2 plus 7.2 plus 7.2 plus 7.2 or 7.2 times 4. Okay. Find your perimeter. And that's it. So what's the answer? 28.8. So for the next 2 days, today and tomorrow, you're really just working on the EOC reviews I gave you. Tomorrow, I'm not giving you a piece of paper. So you can work on this one if you want. You can work on the one I gave you on Monday first. That would probably be smart. Yeah, you got to do those too. This paper I'm checking on Monday because it's technically the EOC review paper. The one I think you should work on is the one with the star on the board, EOC triangles and quadrilaterals. I gave that to you on Monday. Technically due at the end of class tomorrow. You can work on it in class tomorrow. So I would work on that one first. It's the one I gave you Monday, triangles. It looks like this. Where is it? I just tapped it out. Oh, it looks like this. Oh, my son looks like round. It looks like this. It's got like parallel lines. And there's a bunch of like triangles all over it. So I would work on this one first and then work on that one next. But what do I do? You know, just an idea, just a concept. Let me know if you get stuck. Let me know if you need help. And if you're copying other people, you're only hurting yourself because you can't pass the EOC to that mic. You're just gonna cry to me and then you're blame me like you guys blame other people right now.
Okay,